couldn't attend today?
Okay, we're ready.
Yeah. Thank you, Linda, and good afternoon, everyone. Welcome to our spring edition of the Research Partnership Board meeting. And first, we will go around with introductions. I will go with the list in the order I see on my screen. So let me start with myself. My name is Mani Venkatasubramanian, and I am a faculty in electrical engineering here at WSU. And I also serve as the director of ESIC. Arif?
Hi, I'm Arif Khan. I work at Software Engineering Laboratory as a development lead research engineer, primarily working on developing algorithms for power system analytics. And we develop software products, and the analytics or power algorithms go behind the software. I pretty much work on those.
Thank you, Arif, and welcome. Anil,
you.
you joined at just the right time. Anil, could you introduce yourself? Anil, okay. Could you introduce yourself, Anil Jampala?
Yes, I think you asked for me, Manny. I'm Alan Law, and I'm over in the economics department here at WSU, and like working in the power market area.
Welcome, Alan. I think Anil probably cannot hear us, so Anjan, please go ahead.
Okay, this is Anjan Bose. I'm here at Washington State University in electrical engineering and computer science, and part of ESIC.
Jenny?
Hi, I'm Janine Burke, and I'm the ESIC manager.
Anamika?
Hi, everyone. This is Anamika Dubey. I'm an associate professor with the Power Group.
Asifa?
Hi, sorry, it took a while to get the button right. My name is Asifo Gauramadan. I'm a faculty in computer science at the School of Electrical Engineering and Computer Science.
And John Heap?
Hi, John Heap. I'm a principal engineer for Snohomish County Public Utility District.
Welcome, John. Linda Howell?
Yes, hello. I am Linda Howell, and I work for both ESIC and the AGI, Advanced Grid Institute. And for ESIC, I'm an industry liaison, industry relations coordinator, I guess, officially.
Thank you, Linda. And I should thank Linda for going through all the preparations for this meeting, coordinating this meeting, and for all the membership activities. Thank you, Linda. And Jay Landstrom.
Hey, good afternoon, everybody. Jay Landstrom with Portland General Electric. I'm the infrastructure program director here. Currently, I run the corporate research and development program at PGE, but mostly I am responsible for planning and developing programs under the Infrastructure Investment and Jobs Act.
Thank you, Jay, and we are very excited to hear about your new role at PGE. Saeed?
Hello, this is Said Lotfipad. I'm associate professor at EECS, and yeah, I'm part of the power group working on stability, protection, control issues. Thank you.
And Mary Ellen?
Hi, I'm Mary Ellen Martinson. I work at Power Engineers, went to WSU, really interested in trying to help with recruitment at WSU. And I mostly work in system protection and a little bit of system planning, and have a background in substation.
Welcome, Mary Ellen. And Mike Larson? Mike, you may be muted. We will come back to Mike. Darlene.
Hi, Manny. Hi, everyone.
Darlene
What?
is our. Yeah,
I
go
just
ahead.
jumped on, sorry.
Oh, okay. We caught you off guard. Darlene is our finance, the projects manager at ESIC, and one of the crucial staff members of our team. And Sanjeev.
Thank you.
Yeah, hello everyone. This is Sanjeev Panala. I'm working as research assistant professor with ESIC.
Manu.
Hey everyone. This is director for VAMS and Advanced EMS. Can you hear me okay?
Yeah, your voice cut out a little bit, Manu, at least on my end.
Sure. Okay, let me come again. So,
okay.
Hi everybody, I work for GE. I'm the product director for our VAMS and EMS product lines.
Welcome, Manu. And Kevin Schneider.
Hello, Kevin Schneider with the Pacific Northwest National Laboratory. I'm one of the joint appointees with the AGI, and I also manage our portfolio work with the Office of Electricity.
Thank you, Kevin. And Noel.
Good afternoon. I'm Noel Schultz, a Schweitzer Chair in Electrical Engineering, and this is my finishing up my 7th year at WSU, and glad to see everybody.
Welcome, Noel. And Chuck Wells.
Well, I'm Chuck Wells, co-founder of PICE, and I've been working extensively in microgrids and DERMS for the past 7 or 8 years.
Welcome to our meeting, Chuck. And Anil Jampala.
Thank you, Manny. My name is Anil Jampala. I used to work for GE, retired from there last August, and I'm now with PSC Consulting in Kirtland, Washington. And thank you, Linda, Manny, for sending your 2 students to work with us during the practicum week. So we had a lot of fun, a lot of work to do for all of us to jointly understand industry needs.
Thank you, Anil, and great to be collaborating with you on the workforce development. We will talk more about it today as well as in our PEP meeting in a few weeks' time. And we have one person on the phone with the area code starting 425.
That's probably me.
Oh, you, okay. Okay.
Manny, I think Mark Rice just joined as well from PNL.
Oh, Mark, welcome. Please introduce yourself.
Yeah, good afternoon, everyone. This is Mark Rice with PNL. I am the group lead of the Electricity Security Group here at PNL, and look forward to great things. We too participated in the practicum earlier, and then, yeah, just looking for collaboration. So.
Yeah, and I should say Mark is my boss for my PNL. For me and
mine too.
Yeah, I think we're missing Jennifer Boyer and Mike Larson are 2 that we have not introduced
yet. Yes. Jennifer, please go ahead.
Hi, I'm sorry I joined a few minutes late too, so I probably didn't make your initial list. Jennifer Boyer, Puget Sound Energy. I'm the Director of Engineering, and we also had a blast hosting some students a couple weeks ago.
Welcome to our board meeting, Jennifer.
Thank you.
And Mike, are you able to talk now, Mike Larson? Okay, maybe not, Linda.
Okay.
We can try maybe later in the roundtable.
Is there anyone else that we have missed? We have tried to catch everyone, but the names keep on moving around. I believe we have if we have missed you, please say something, but I believe we have everyone.
Okay, thank you. And now we can, maybe I will start with the quick update from ESIC, and then we can continue with the rest of the agenda. And can you see my screen, Linda?
I can see it, yes.
Okay. Welcome, everyone. And as you know, this year is very exciting as we are entering the 50th year of the Power Professorship Program, which was founded back in 1973. And also, this is the 10th year anniversary of our ESIC as a center. This was founded back in 2012. And we have a threefold mission here at ESIC. Education is high priority for us, especially being a land grant university, and also working with all of you and the government in advancing the needs of the power industry, and research being our main focus as a research center as well. And the main announcement today is our plans are well underway for the 50th year celebrations of the Power Professorship Program. And we are still doing some research on who all were the founders of the program. And from what I understand, the three people that I have mentioned here, Dr. Ati Betts, who used to be the chair of electrical engineering at WSU back in the 70s, 60s and 70s, and Wendell Satter from Washington Water Power Company, which is now Avista, and also Axel Strom from Grand County PUD. I'm told they were the three main founders who established the program back in 1973. So we want to recognize the contributions of everyone who has really helped us sustain the program for 50 years, which is really remarkable. And we want to celebrate this success with all of you. So we are planning. Any questions or comments? And we are planning several events possibly for the 2023 academic year in recognition of this 50th year anniversary. And the main event is going to be likely on the 15th of September. And it's a Friday, probably all day event that we are planning here in Pullman campus. And the idea is there is a home game the following day versus Northern Colorado on the 16th, Saturday. So some of you may think of coming here. We invite you to visit us with your family. You can spend some time in our campus, as well as maybe going to the game on Saturday. And we are holding rooms for all 3 days, 14th, 15th, and 16th. And Linda will be sending you details with the hotel information, as well as some preliminary plans for the day celebrations. And we are very excited to be planning this. And we hope that all of you will be joining us in the celebrations. It's really because of your support that we have been able to continue this, and we look forward to growing the program and continuing our success for the next 50 years. So that's the main update for today. And in terms of faculty, for some of you who are joining the meeting for the first time, as you know, we have a very strong program here in power engineering at WSU. And also we are unique that we have power engineering, which is under Pullman, but being taught in 2 other campuses. On the west side, we have a campus in Everett, which is managed by Dr. Shu Shi, who is teaching focus faculty in the Everett campus. And we have Dr. Javier Guerrero, who teaches power classes for us in the Bremerton campus. And we have faculty in distribution, in transmission, in operations, and in protection. And also, like Kevin mentioned, we have PNNL scientists who are joint appointees here, who work as faculty at WSU as well. And we also have faculty in our Vancouver campus who are core faculty in our center. Professor Josh and Professor Hong Gao are in the Vancouver campus, and they supervise PhD students from our Pullman program. And some of you may recall we lost Anurag, who left WSU and went as the chair of the electrical engineering and computer science department at Western Virginia University in, I think, in 2021. But he still has some funding and students here at WSU. And we also have faculty in various other departments, including Alan, who is here with us in the meeting. Alan works with Anamika and with the rest of us on several projects related to the power grid. So essentially, any faculty who has interest in power grid is a member of our ESIC center. And this includes faculty in chemical engineering, in civil, in computer science, and in communications. So that is one of the unique strengths of ESIC, that we have multidisciplinary research that we facilitate. And in terms of our future plans, we have a current ongoing search. We have a faculty opening in power electronics and then one in power systems that we are recruiting at the moment. And Professor Noel Schultz will provide an update on the status of the search later in the meeting. And also, we are excited to say that we have a new cybersecurity degree program that we are offering in EECS, BS in cybersecurity. And as part of that degree program, we have a current search for several faculty in cybersecurity who will be joining EECS in fall. And we again hope to be working with several of them on power grid applications. So we will become especially strong on cybersecurity here at WSU. And in terms of staff, I think we met Janine, Linda, and Darlene. We also have Tiffany, who works on the UASS project that Novel leads. And also we have Sam, who is a student in, who is an honor student, and she works with us on TimeSlip, helping us with the web page and communications. In terms of students, currently we have about 30 PhD students, and we don't really take a lot of master students. And the number of students in the power senior class is a little small compared to a few years ago. So we are still going through some of the after effect of the pandemic when we lost some students. But the good news is the number is on the increase, as we saw this practicum when we had our students going to the power companies for 1 week internship training. This year we had the largest number. We had 35 students who participated in practicum, and we had 12 hosts for our students this year. We thank all of the companies, including power system consultants and PNNL, who were new hosts this year. And we really hope to grow the program in the following years. And we will talk more about that in our PEP meeting in a few weeks' time.
May I ask a question?
Yes,
Sorry.
please go ahead.
Do you know why you have such few students entering the master's program?
Oh, why so few, you mean?
Yeah.
Okay, that was kind of the way the research is designed, that it's more geared towards PhD students. In fact, all of our graduate students are funded by research projects, excepting the 2 non-thesis students. And for the kind of research projects we have, PhD students are more suited. And the university also has a preference in us taking PhD students, which count more towards ranking versus master students. So the few master students we take tend to be American students. And so for, did I answer your question?
Yeah, this is Mark Rice. You gave me the reasons, and that's fine. I was just shocked by the difference in between the two
Yes.
numbers. So.
Maybe Noel, do you want to comment on that? I think this is the direction we got from the administrators, at least from what I remember, that the PhD students are the ones that count towards ranking and not the master students. So there was a gentle push towards going more with PhD students versus master students. And also, like I said, from the nature of the projects, it lends more towards hiring PhD students rather than master students who basically do research for 1 year and then they leave. 1 year is coursework and then 1 year of research. Whereas PhD students stay longer. And so we can get more productive research accomplished with the PhD students.
Yeah, I'll just make, I think we did move towards the PhD students. We do have some non-thesis students that we have going through, and master students that are doing research. I think if that's something particularly our partners thought was important, we could start to look at that more and what would be some opportunities related to that. And I think one of the challenges is having enough, if you have funding for a couple of years, you're going to look for a PhD student because, like Manny said, they'll be around a little bit longer. But if that's something our partners, we're interested in, that's something we could talk about on how to provide support. But right now, we only offer TAs to PhD students in EECS. And that goes back to kind of Manny's point about rankings and some of that. But if it was something we need to do, we could talk about that more.
Yeah, that's a good point, Noel. So please let us know if you think this is something that we need to improve on. Definitely, like Noel said, we will look into that. And we can talk about it maybe in the roundtable discussions. And again, in terms of funding, the effect of pandemic, the number is still a little down compared to what we had before pandemic. And hopefully with all these infrastructure grants which are being announced and several that we have also submitted proposals, this number should be ramping up in the next few years. And I know I'm a little bit behind time, so I will quickly wrap up. So these are the key research strategic areas that we decided a few years ago. And maybe as part of the 50th year celebrations, we can think about where we should be focusing on in the next 10-15 years. And that can be a topic for our September event. And just as a reminder, we have this GE Smart City testbed here at WSU, where we have commercial grade EMS and DMS that we use for testing our applications and also for showing these to our students here at WSU. And we have a small solar test bed, and we are trying to get batteries as well as bulk energy batteries, as well as microgrids and John Gibson is going to talk a little bit more about that initiative later again today. And I will skip this one since we are running behind. And again, just as a quick recap, we thank you for the 2 partnership programs that we have as part of the ESIC Center. One is targeted towards education, and this is the Power Education Partnership, what we call as the ESIC PEP membership. And then we have the Research Excellence Partnership, which is more geared towards the graduate students and research. And today's meeting is on the REP program. And the REP membership is $15K a year, and it gives essentially access to all of our research and being part of our research projects and in close collaboration, in working with us in close collaboration. And these are the current REP members. And in terms of the PEP program, the funds are used for supporting the practicum that we briefly talked about. And also it provides the opportunity to facilitate internships at the member companies. And also you serve as our advisors for the power curriculum. And we can talk more about it during the PEP meeting. And these are the current PEP members, and we are excited to welcome Tacoma Power, which has come back into the PEP program as of this year. And just as quick, again, just as a note, we also offer the online degree program in power engineering. This is managed by ESIC, and we have students all over the world, and we are going through the process of revamping our curriculum based on feedback that we have received from our students who graduated and by listening to some of the stakeholders. So if you have any feedback on what you would like to see in terms of courses and topics in our online degree program, please let us know. So I will stop with that. And I think next on the agenda, what do we have, Linda?
It's a research overview,
Okay.
and with Anamika starting.
Please go ahead, Anamika.
Okay, thank you. How much time do I have, Mani?
Yeah, I would say about 5 minutes each, Anamika.
Okay, great.
I know you have a lot to cover, but I know you
No,
can
no.
speak fast.
Yes, sure. So, hi everyone. Glad to be here, and it's really nice to see you all. As I mentioned, I'm an associate professor with ECS department here at Washington State University, working with on Power Grid affiliated with ESIC. I'm also a joint appointee at Pacific Northwest National Lab as a research scientist. And I'm going to briefly talk about what is the main problem area, what my research focuses on, and what are some of the ongoing activities. So I primarily focus on electric power distribution systems, and I look into how the system operations are changing and what are the challenges as we are integrating more and more grid edge resources. So briefly, just to highlight the problem, one of the examples is, of course, photovoltaic installation. So we are seeing a large number of PV integration at the distribution level, and this is not just energy, but or kilowatts or megawatts, but also the number of PVs itself, and that their uncoordinated operation can lead to several kinds of system level challenges. For example, operating limit violation, protection issues, unbalance, etc. And currently, they are more of a nuisance to the grid. However, if we can coordinate their operation, it can actually improve system efficiency and help us better manage the operational constraint. So that's one of the concerns, that lack of active management and operation of these resources leads to underutilized infrastructure. So how can we look into active grid management? So that's one question. Similarly, we are seeing this trend from transportation electrification, from building electrification, from transportation, for example, there's a number that 3 million electric vehicles are currently on US roads. Similarly, at building electrification, we are looking into 40% of country's energy use, which comes from natural gas as a primary heating fuel. Some part of it may be shifting to electric, electricity. And this is one of the plots that is really interesting in terms of different projections of how these high electrification goals are going to transform in terms of energy requirement. And this will, of course, contribute to also not just the capacity constraint, but also delivery constraint. So this is somewhat, expected to happen, and it might be a nightmare of a situation from distribution planning and operations perspective. So once again, this coordinated operation of these resources, they all can provide some level of flexibility. And if we can coordinate their operation, it can provide added operational flexibility. So I look into how we can provide, active grid management through grid edge optimization and control to unlock this operational flexibility. The third issue at the distribution level comes from extreme weather events. So we are looking into major outages that are happening at the distribution level damages because of these extreme weather event. And in fact, the cost of these outages are huge. These are not just causing damage to the grid, but also some of the situations where we have to do the planned outages because of, let's say, heat wave. And different types of events can lead to different types of impacts on the distribution system. However, this question then, of course, is there that can we coordinate the operation of these advanced grid edge resources to provide resiliency services, for example, by self-assembly or local support. So my research basically looks into these questions, tries to figure out how do we develop detailed models for distribution system with these grid edge devices? How do we use these distribution level models to look into different types of solutions with the help of different optimization algorithms? And how do we really look into formulations and solutions for these algorithms so that they can scale at the level of changes we are expecting to see in the system? We look into different types of application cases that I mentioned in the previous 3 slides. We look at operational decision making, long-term planning for resiliency, for example, or even operational planning. We also think about what granularity of power grid model and device models are needed to actually make it happen. What kind of enablers are needed at the distribution system for to make these changes or to unlock these operational flexibility at the distribution level. And we also basically ask this question that how do we leverage the data to make better decision along with the models that we have available. So these are some of the basic questions that I analyze in my research. We very actively collaborate with national labs, utility companies, and vendors. These are examples of some of the ongoing projects where we look into how to really develop these algorithms that can be deployed and field demonstrated on utility company or even with the help of some sort of open source demonstration. So some of the active projects include this Grid Apps T project, which is basically an open source platform for advanced distribution management system in collaboration with Pacific Northwest National Lab. Citadels is another project where we are subcontracting with Pacific Northwest National Lab, and we are looking into how can we unlock the flexibility offered by network microgrid for different kinds of grid services. The third project is subcontracted through Avista and EDO, where we are looking into how to deploy some of the distributed coordination architecture to make these, operational flexibility from buildings available for different kinds of grid services and also field demonstrated. And the last one is a recently funded project through CETO, where we're looking into deploying and field demonstrating some restoration solutions with the help of open source layered architecture at the distribution level with the help of grid edge devices. This is my happy group. I just wanted to acknowledge all my students and all sponsors for funding this research for past, this is my 8th year. And with that, I'm going to stop. Hopefully I didn't go above my time. Thank you, everyone.
Yeah, thank you very much, Anamika. You are right on time.
Okay, and, awesome. Thank you.
Next is, I think, Saeed.
Sure. Let me share. Okay, I was looking for the shared buttons. Oh, no.
Oh, the share button is right on top next to.
Yeah. Can you see the slides? Yeah.
Yes, please go ahead.
Okay, good. So hello, good afternoon. I'm Saeed Lotfifard. I'm associate professor at WSU. I'm here since 2014. So basically my research background is on the operational security of inverter-based dominated power grids. So we look at mainly on the protection, stability, and control issue of when we have high share of IBRs. So the challenges that we are looking at are when we have new IBRs and with high share of the IBRs integrated into the power system, we face new dynamics and new fault response characteristics. So the question is that how can we address these problems? So from the digital protection and the protective relays distributed to the system, from the controller hosted at the inverter interface, and the communication-based control that coordinates the IBRs. So some of the works that we are doing, I have listed here. For example, one major work that I'm working on for so many years are fault management in distribution system. When we have a different type of IBRs, how to develop protection, fault response tools and technologies such that we can deal with the different fault characteristics of the inverter-based devices and bidirectional power flows and fault current contributions. So the same issues that, because when we want to do the fault analysis, we have to have a observability of the fault. So then this basically one of the projects that will end in this summer. So we are working on basically utilize the physics-informed and data-driven methods to make the system observable for fault analysis. So basically combination of the machine learning tools and physics-based analysis of the system. So another work that we are doing, this is mainly for transmission lines. So basically we want to see that if we have if huge amount of the data from protective devices are collected at the control center, how to make sure that we can make the tools available to the system operator such that be more situation aware. So basically here we are working on different graph theory and data analytics methods to kind of find the root cause of the problem based on the data we get from the protective relays, we get from the different alarm processing devices, and so on and so forth. So another work that also related to the same problem. So if we have a fault in the system, so we are not only should disconnect the faulted area as fast as possible. Also, we should make sure the inverter remain connected to the system, contribute to the post-fault condition of the system, and stability of the system. So basically, these are all related to how you interface inverter to the grid during the fault. So basically here we are using different nonlinear theory, multivariable control theory, robust control, and so on and so forth. So to improve the basically grid synchronization and stability of inverters. So the same type of problem, we are looking at the also interaction between protection and control of the inverters, because again, due to inverters, some of the protection devices are vulnerable. So how to detect them, how to address the problem, either by proposing new digital algorithms or just by simply changing the settings and coordination of the relay. So basically, all of these things are issues related due to high penetration of the inverters. So that's one thing also we are working on. That is basically, it's run in my group for so many years. So what we are thinking about that, if and of course we know that the inverters controllers, they have some shortcomings, but at the same time we know that they have a lot of strengths which have been built up for so many years. So the question is that can we just attack those shortcomings and solve that issues, at the same time preserve the strengths of the inverters? So to address this problem, we have developed the supplementary controller. So we keep the conventional controller in place, and then we supplement them with the extra supplementary controller. And we have shown that it has a lot of advantages for so many cases. For example, here is a case of the WIC grades and so on and so forth. So the same things. So the problem of weak grade is not just the system become weaker. The problem here is that you have a sudden change in the strength of the system. It had been observed in the Arizona at so many places, and also at the low voltage system, at the microgrid, also we observed that issues. So for the sake of the time, I just passed this few slide. I think I'm on the five minutes. So So then, yeah, the same thing we have done for secondary control of these things, so that how coordinate that one such that we can improve the response of the controllers. So the same thing for HVDCs and the AC system. So how to coordinate this type of system that are totally different. So by that, thank you. And now if you have any questions or comment, I will be happy to chat with you offline. So thank you.
Thank you, Syed. You also finished right on time. Thank you.
Thank you.
Next, Sanjeev. Yeah, you think you need to stop sharing, Syed? Linda, who do we have next on the agenda? I don't seem to have the latest agenda. I'll try to find it.
It's Sanjeev,
Okay.
but maybe he had to step away for a minute.
Okay, who would be next?
Asifa?
Yeah, I can go next.
Yeah, please go ahead. Yeah.
Yeah. So it's a pleasure to be here again. It's always nice to hear the activities that happen in ESIC. I am a computer science faculty. My area is in data science and AI and high performance computing. And those applications bring me in touch with a number of colleagues here. With Anamika, for example, we are working on reinforcement learning to some of the problems that she's working on, and a number of other examples I can say. So my primary area is in computer science. But to piggyback on what Mani was saying in terms of cybersecurity, I just want to give a highlight on a major effort that we have here at WSU. We are excited about starting a new degree program in cybersecurity starting from fall. It was heavily involved in the kind of paperwork that's needed, design of courses for it that's are required, and we are all in approved except for one institution that would allow us to recruit students. As something that has laid into it, there is an institute at WSU called Cybersecurity Education and Research CISR that's funded by Department of Defense to try increase cybersecurity knowledge in the US workforce. It's primarily meant for undergraduate education, but we have also incorporated graduate education in terms of research and experiential learning. So if this is going to work, I will share just the website so that you can see some of the things that happen there and highlight.
I don't know if you are sharing
things.
anything, Asifa. We are not seeing.
No, I was not sharing anything,
okay. Okay.
And that the goal was not to share. I just
okay.
wanted to talk through. But if this comes, let me try to share the website so you can see. But I will continue to talk about what that institute does. Let me see. Do you see now? All right. I'll just continue. Do you see?
No.
Update driver looks like your audio driver. No. All right, I will just continue to talk about. This is a Department of Defense funded institute that WSU leads, and it has multiple institutions in the Pacific Northwest, University of Idaho, Montana State University, Columbia Basin College. And the goal is to expose students to experiential learning around cybersecurity, in particular cyber operations. And we had designed, yeah, that's great. So this is what the website looks like, and that's probably enough for what I wanted to give you a highlight on. We designed courses and made ways in which students would get additional experience in addition to what they get in classes. Some of them were around research mentored with graduate students. We have a 2-week summer workshop that is very intensive, where great industry speakers would come and talk about their cybersecurity related works. We had also tutorials and sessions that are laid for multiple hours. Last summer, we had a visit to PNNL and SEL. Both of them had been great participants. We had a presentation on industrial control systems by Nathan Keep last year, and we are hoping to get a similar kind of presentation this summer as well. The field trips to PNNL and SEL were enjoyed by students. We just completed, we're now completing our second year through this funding. And I was at a symposium last week where the DoD program that funds CISR was trying to see next steps, and we are in a good position to be funded for another 1 year. And there is an excitement around the new cybersecurity degree program that is started. This is led by a number of us, including Noel Scholz, and there is a large number of students that are computer science and software engineering students, but one of the unique natures about the program is that it has room for multidisciplinary research and electrical engineering students, either in their capstone courses, in senior design courses, or in the summer workshop are great opportunities to participate. Cyber physical systems is one of the core areas, and among our seminar speakers this semester, 2 or 3 of them were in cyber physical systems, including a new faculty we have here at ECS. So this was the kind of highlight I wanted to give you. Big investment and excitement around cybersecurity, both in terms of research and education, and I'm happy to be playing a role in there. So I know we are pressed on time, Mani. I will be happy to stop here,
Okay.
And I can take questions if there are any.
Yeah, thank you, Asifa. And also I want to mention this year in our practicum program, we had 2 students from computer science and 1 student from computer engineering who went to power companies as part of the spring break practicum training program. We are excited to see that power is becoming popular with students in computer science and computer engineering as well, because we certainly see there is a need for them in the power industry. So that part of the program we hope to grow in the coming years as well. And we appreciate all the collaborations with our CS faculty, such as Asifa. Thank you, Asifa. You bring real insight from CS for our applications. Thank you.
Thank you. Thank you.
And Noel? Noel, you are next.
Hey. Good afternoon, everybody. I'm going to share a little bit about UI Assist, which is a project that, oops, let's see what's happening there. Okay, can you all see this okay?
Yes, yes, please go ahead.
Okay, so UI Assist is a project that's in its 6th year. We're 5.5 years in. It's the US-India Collaborative for Smart Distribution Systems. It's $30 million. WSU is the US lead with 15 organizations across the US. And it's a really interesting project to go all the way from R&D to lab demonstrations to field demonstrations. And we're also looking at policy, social impact, and social impact research. There are a lot of collaborations. I can give you a whole hour seminar in this, but I'm just going to give you the 5-minute snapshot. But we have US, India, and US-India partnerships that we're working on. One of the great things about this project is our work with industry. And we're very fortunate to work with Avista and Spokane, both with their lab, Smart Grid Lab, looking at some volt var control. I'll talk a little bit more about that. We also have a battery backup we're going to be putting on the Pullman campus with sensors that we can use. We've also worked with Snohomish PUD in a couple areas, but one of the things we worked on is a senior design team did a feasibility study around with Tulalip Tribe. And that was a really cool opportunity for our students to see real life. And then we've worked with Opalco also in the San Juan Islands on looking at some renewables and opportunities for storage. I'll talk a little bit. One of the coolest parts of the project is that we've electrified 2 hamlets in India that's been part of it. This is a really large, lots of different partners, and I'm not going to go through all these, but just showing from the university side, we have Washington State, MIT, Texas A&M, University of Hawaii. Snowput and Avista are two of our partners, as well as 3 national labs, PNNL, NREL, and Lawrence Berkeley, and then some other groups across and NRACA. So it's really a large group of different people that are working on this. I just wanted to share a little bit about, this is the pilot, the rural pilot in India that we're actually working with. And we're actually working with IEEE to try to get this as a IEEE microgrid standard. So it's taking us a little while, but we're looking at this where we're actually using solar as well as a biodigester for electricity in India at this different group. And I know there's a lot going on in this slide, but it really is pretty amazing when you think about electrifying a village for the first time and them being able to have lights. They also have some solar water pumps, so it helps in agriculture and other ways that they can have reliable electricity. Some of the US pilots we have going on, the battery, the top one is the WSU system, top left, and where we're integrating our battery into the system at McCluskey Hall, which is where our facilities is. Avista, we're working on some volt var control and looking at also some work with some markets that we've been talking about. Snohomish PUD, we're looking at some of the different data they have around their battery system and looking at how can we work on different projects related to predictions and control. And then, as I mentioned, Opalco, we're also doing some work. So we're really fortunate to have a PUD, a co-op, and an IOU involved in all the different activities across UISys. And as we kind of look as we wind down UISys in our 6 years, there's a lot of different test beds that have been built across. There are a lot of partnerships that have been built across the US and India. And I think it's really going to have a lot of momentum moving forward as we look at advanced distribution systems and microgrids. There's a lot of different models and tools that are coming out of that. We're also in this last 6 months, Anjan is working on looking at some of the policy and market structures as well as standards. Where are some of the gaps? And we've worked with Christine Horn in sociology to look at some of the acceptance, as well as our India partners are doing that. So I really think this has been a great opportunity for WSU, but to really be involved in this really large project with a couple partners that we have here online today. So that's pretty much I have a couple other projects, but this is my working with Asifa, and with this particular project, Asifa has been part of it. Sanjeev is the technical lead for WSU and has really done a great job. So I think that's it for me.
Yeah, thank you, Noel. Really exciting project, and I'm personally happy to hear about the electrification of remote villages in India. I know some of those places there is no access to power grid, and so it's really amazing that you are able to provide lighting and water facilities for those villages. Thank you, Noel.
Thank you.
And Anjan?
Okay, so let me just say that I do a lot of little things for different projects, and I am working on a couple of the projects that Anamika talked about, and I work on that project that Noel just talked about. But I thought instead of talking about these kinds of details, I'll talk about two fun things that I've done in the last few months. One is the project that we've done with Avista on one of the Clean Energy Fund projects from the state. And this has to do with the campus, the WSU campus up in Spokane, where Avista decided to put some photovoltaic systems on one of the roofs of the WSU building. And also on that same feeder, there were some batteries. And so this was a kind of a test of how we can coordinate batteries and photovoltaics with the building. And I won't even talk about that. We did lots of simulations and got results and tried to see if transactive energy would work and all that. But there was what I wanted to mention was the kind of a byproduct of doing this was that we set up a system where we could import the data from Evista's feeder directly into our research labs. And this has been kind of not very, I don't know of anybody else who's been able to do this at an university lab, but we download the data from AMI and from the SCADA system into our database here, as well as update the database for the feeder details as they change. And during these years, that every feeder is like that in real life. They have to be changed in various ways, and we get to update it as so. And I know that this particular platform, I should say, will be useful in other studies. And I think later on you'll hear how Evista is very involved with a much bigger project that would utilize this ability. The other thing I wanted to talk about was a workshop that I was very involved in running. And I'm going to see if I can actually put up the first page of the workshop report. Can you see anything?
Yes.
It's
No?
coming. Yeah. Yes.
Oh, you can see something.
Yes.
It's the first page of the workshop report that came out of it. And as you can see, the title of this workshop, it was done under the National Academy of Engineering in last October. And as you see, it has a very long name called Creating a Sustainable National Electric Infrastructure while Maintaining Reliability and Resiliency of the Grid. People started referring to this workshop, not with that title, but to say, make sure to keep the lights on while you're saving the world. But it was a fun workshop because we had something like 40 people in one room in Washington, D.C. And these were people who came from not just the technical side. We had pretty much a lot of power engineers there, all the way from little PhDs to ISOs. But we also had people from the regulatory area. We had NERC and FERC and NERUC, and then of course the research agencies like DOE, and so there was a lot of talk about it and discussion about what are the challenges of this big transformation that we are embarked on already of changing the grid, and I think most of us, of course, who are doing this kind of technical research are very aware of the fact that the tools that we have to do things, whether that is be the modeling of all the new technologies or even the methods of calculating availability of generation, reliability of generation, and all of those. There are lots of technical things that needs to be developed, but we also flagged a large number of regulatory and policy issues that will have to be straightened out or at least coordinated before some of these things will work. It's probably the biggest one is that our distribution systems are now regulated very differently from our bulk transmission. and how that needs to be reconciled while a larger and larger proportion of the generation is moving to the distribution side remains to be seen. So, by the way, this is available to anybody who wants it. It's on the National Academy's website, and I will actually give the website address to Linda to put in the meetings of this this meeting right here. So that's it. Thank you.
Yeah, thank you very much, Anjan. Really like the theme of that workshop and look forward to reading the contents. And that kind of leads into what I was going to say for my part. And let me share this presentation, and I will try to go through it quickly. And this is a slide that I have been using for some of the discussions on the evolution of the power grid for the future. And this is a picture that I got from EIA, and it shows the energy consumption, the total energy consumption, not just the power grid. This is the total energy consumption by different sources in 2021. And what is striking is even today, or at least as of last year, almost 80% of the energy was coming from fossil fuels. And if we also look at what we can think of as sustainable energy sources, which is possibly nuclear, wind, and solar, all of those energy sources are tied to the power grid. They are all electrical energy sources. And so if we have to move away from fossil fuels towards sustainable energy sources, that means all of this energy demands would have to be met in some form or other by electrical energy. And this just seems like such a challenging problem that we have to scale up the power grid and possibly move some of the energy sources closer to the demand. So not all of this needs to go through the power grid necessarily, but it would have to be somehow connected to the power grid. And that is the grand challenge that we have, in addition to the resiliency and the reliability that you mentioned, Anjan. And I show this slide. We have groups of high school students who visit our WSU campus, thinking about what programs and possibly what engineering disciplines to choose. And I encourage them to come to the power engineering, because I say that we need more power engineers to solve the societal problems for the future. And this is like the general theme for our ESIC as well. And in terms of my own research, as some of you know, my focus has been on the monitoring of oscillations in the power grid at various levels for inter-area modes and more and more now the subsynchronous oscillations coming from the inverter-based resources, how we can monitor them, how we can control them. And I will also mention the tools that we developed here at WSU. They have been licensed by RTE France, and it is being used in the Paris Control Center for the monitoring of modes in the European interconnection. And we are also working with SCL on developing some new methods for source location of forced oscillations. And we have a project where we are integrating our tools into SCL SynchroWave for visualization, and that is funded by SDG&D. And in terms of controls, we are working with the RTE on the designing of possibly some probing signals, because in Europe, they don't really have good dynamic models for the interconnections. So they are forced to do the designs on the go using online measurement-based methods. So we are working with them on system identification, how we can find the transfer functions, and then design controls such as for HVDC modulation to damp out inter-area modes. So that's an exciting project, and we are working on the modeling of IBRs and how we can identify which parameters would be important in determining the dynamic properties of the bulk power system. Because we need to know what parameters we need to or we need focus on, given the complexity of these modern inverter-based resources. And especially as the number becomes larger, we need to have some specifications or standards on what or how they should be behaving. And another area that we are working on is to develop model validation toolbox, both for synchronous machines and IBR, which will be an open source tool. And this is going to be based on the RTE Dynavo platform that they are developing, which is an open source transient stability simulation tool. So since we are out of time, I will stop there and we will transition. And on any of the faculty presentations, if you have questions, please feel free to reach out to us, and we would look forward to hearing from you. And with that, Noel, please proceed with the search update as well as the AGI update.
Okay, the search update, and many of you should already know as you're getting our emails. We have 5 candidates that are coming in, or we've had 3 come in, and we have 2 more. We have one on Friday and one on next Monday. And we're hoping after that to be able to make some offers. As Manny mentioned earlier, we're looking in the areas of power electronics and power systems. So those are what we're working on to fill those positions. So as you may remember, we had a search last year and we weren't able to get our top candidate. Well, we weren't able to get our candidates what we wanted. So we delayed it a year and started a little bit earlier. And so we have a really strong pool, about 180 to 200 candidates that we've gone through. So hopefully you're participating, or some of your colleagues are participating. We'd love your feedback. I think Janine's been sending that out to people that participate. And you'll get more information on Friday and Monday's candidates. So any questions on the search?
And I have seen some participation by our members, and we thank you for your feedback as well.
Anybody else? Okay, so AGI next, Manny?
Yes, please. Yeah.
Okay, let me try to share. It's got kind of a new thing going here. See if I can make this work. Okay, so hopefully my slides are and you can see them.
Yes.
So there's a new Teams tool with PowerPoint, so I'm learning along the way here. So I want to just talk about the Advanced Grid Institute, which is a PNNL WSU, and many of you know about it and have been involved, but just for some of the new folks, kind of to provide a background. Jeff Daigle and I are co-directors on this, and AGI started in 2018. So actually next month we'll be done with 5 years. So I guess we're celebrating 5 years as well with AGI. So lots of anniversaries this year. So some of the different activities that we're doing, advanced modeling for the complex power grid, realistic environments for testing and training, and then convening industry thought leaders and stakeholders, and then preparing the next generation workforce. So obviously there's a lot of overlap with ESIC, and we meet with Manny every other week to just see how we can work together. So a little bit about our mission and vision, and then kind of a big set of different activities that are going on, and then to kind of focus on a few. Our mission and vision, you can see there. Our joint projects, we have about 10 multi-year projects across projects between PNNL, WSU, over $50 million. Obviously, with some of the new DOE calls, there are also going to be some additional partnerships. We also had a collaborative, some of the internal funds that what's called LDRD, our Laboratory Directed Research and Development Funds. We had a grid sandbox, which was a collaboration between WSU and PNNL. And one of the other unique opportunities we have is a Distinguished Graduate Research Program, where a student works for 2 years in Pullman and then goes to spends 2 years at PNNL. And earlier today, one of our DGRPs, who's now a researcher at PNNL, gave a seminar. So it's really an opportunity for our students to see the lab experience and work with a lab mentor and work on research there. We've had 6 joint appointments since the inception. Right now we have 5. And we've also had several internal AGI days where we do presentations between PNNL and WSU. And our PNNL colleagues are also interacting with our EE candidates. And we've actually found an interesting part of a lot of our candidates. One of their big interests in WSU was the opportunity to also work closely, not only with industry through ESIC, but also with PNNL as a national lab. We're doing publications, and I'll talk a little bit about our monthly webinars. We also have an e-newsletter that's coming out. It'll be coming out in mid-April. If you're not on that list, you can let me know, and we can make sure you're on that. And then our strategic plan, which we developed in 2001, we're working on next steps with that. So one of our big activities for 2023 is our advisory board. And there are representatives from many of the folks. Some of the folks are on, as well as your organizations. And what we're trying to use the advisory board is for a sounding board on what are things we should be doing, and discussions on some of the different aspects of what we're doing. So we had our first meeting. We're meeting quarterly, and then we will have an in-person meeting once a year. And we're trying to continue with a strong regional focus as well as representation. The other exciting thing that AGI was able to participate in December was the Tech Alliance Policy Matters Summit. One of the topics was the power grid, and AGI was asked to provide a panel on this. And you can see, for those of you who have been on some of these activities, where we had an artist drawing while we were talking about our different topics. And this was really more for non-technical audience, for policy people, legislative staff. And so it was a really great opportunity for us to talk about some of the pressing issues, the challenges, and the opportunities that we see moving ahead. The other thing we have, we partner with ESIC, and we have an AGI seminar once a month. And here you can see earlier today, Monish gave a talk on transactive energy, and you can see some of our other topics this semester. These are all recorded and available online, so you can go and see them afterwards if you missed them. And then Anamika talked about one of her projects, and we'll be getting some information on that next month. Well, she'll be talking about her new project on resilient communities. The AGI Day, something we started a couple years ago. I think 2021 was our first one, and 2022 was our first actual in-person one. We had on the WSU Tri-Cities campus, we had about 70 people as well as 100 people online. We had 76 organizations represented, including 14 utilities and 17 universities, actually from 6 different countries. So that was kind of interesting. We also had DOE, EEI, and several state agencies participated in that, as well as staffers from 2 of our United States senators and 1 US representative for the state of Washington. Lots of great discussions, and there's this videos are available if you'd like to go back and see. We had some public utility commissioners, we had industrial panels, as well as talked about the Washington Clean Energy Fund. So you all are getting ahead of our public release, but our AGI Day 2023 will be August 30th from 9 to 4, again on the Tri-Cities campus or online. And our theme, hot off the press, is Pathways Towards a Clean Energy Grid. And so we're working on the agenda now. So if you all have speakers either within your organization or speakers that you've seen at different activities that you'd like us to reach out to, please provide that information to me, and we will follow through with that. So we're looking for different panelists. And so any suggestions, we'll really appreciate that information. The other thing we've really started to work on is external communications, and how do we share the stories about what's happening. You know, as we talk about ESIC and AGI and WSU and many of our partners, there's a lot of great things happening. So AGI, we have a quarterly e-newsletter. We started a blog where we have some messages on things we're doing. We have a Twitter account as well as a LinkedIn account to share some of the different activities. And we continually are working with our PNL communications as well as other partners on our research projects to look at how do we share about the great things that are happening with WSU and PNL and its other partners. So with that, I'm going to just finish with Jeff and my contact information. If anyone has any questions or would like more information, please feel free to reach out to us. And we appreciate, Manny, the opportunity to talk a little bit more about kind of what's happening in AGI right now. Any questions?
Thank you very much. Thank you, Noel. And I should also mention on the ESIC website, we have the recordings of all the weekly seminars, like you mentioned, Noel, and also some of the current ongoing projects as well as publications. They are all available on the ESIC website. And next, we have an exciting new initiative that John Gibson from Avista is going to talk about. And John, you joined late, so please introduce yourself, and then you can continue with the presentation.
Okay, well, my name's John Gibson, and I'm Avista's Innovation Lab Director and Chief R&D Engineer. And can you notify me when you see the presentation?
Yes, we can.
Okay. So, you know, just listening to this group is so enriching with the type of talent that is in this region. And Avista has some very unique challenges. One of them is on the supply side. We have aspirational goals to be carbon neutral by 2027 and to be 100% renewable by 2045. And we recognize that we have a lot of talented people within Avista, but we also recognize that this region is quite unique. It has exceptional talent in the power area. And we think to a large extent that's just evolved out of, you know, all the work that was done on hydroelectricity in this region and renewable resources that has kind of developed a lot of university talent as well as industry talent in this region around the power sector. So we recognize at Avista to be able to achieve those goals, we can't do it alone. We're going to have to bridge out to the talent in our region, and you're seeing that with many of the initiatives that are being talked about. So to be very intentional about that, we also recognize that it's, you know, a convergence is occurring, that this may be once in a generation funding opportunity. And the question that we have at the utility is, how can we bring together a coalition, a broad coalition of talent to help lift this region, be able to differentiate itself not only at a national level, but to attract the best talent in the world to come to this area and study power. That's really the goals that we have in regards to Avista and our partnership. So as a part of that, really enabled to a large extent by Manny and Brian Kraft and others at Washington State, was that we form a group and have a discussion. And so we had a meeting down at U of I Best Western about energy. And it was roughly put together by a bunch of engineers in about 3 weeks, and we had 37 people show up, and they were researchers in industry. And it was clear that this region has a unique capability in power. So it wasn't about a month after that we received a call from Brian, and he says, hey, there's this National Science Foundation out there. They're trying to create these innovation engines that are along the coastline, but rather in the inland reaches of the United States. And could you or would you be interested in putting together a proposal for this? So, and the idea is that you would initially be announced to get roughly $1 million over 2 years to design and implement an innovation engine. And at the end of that 2-year period, you would be in a position to submit a proposal for roughly 10-year, $160 million investment to create this innovation engine in this region. So as a part of that, we put together a concept paper, a letter of intent, and submitted a proposal. We haven't been awarded yet, but I will say there's plenty of traction, whatever that means. And we're hoping to hear in the next couple months on the status of that. But to emphasize or to articulate really this regional capability, this graph here represents under research, industry, workforce, and investment, the various partners that we were able to get letters in collaboration from. In the yellow circle and the blue circle, they all wrote letters of collaboration willing to participate in at least 4 hours of a resource every quarter to participate in developing this innovation engine. But as part of that, we initially submitted our proposal as a Vista, as the lead, but it became pretty clear that the NSF was more interested in an entity independent of the utility to run this type of initiative. And it was really this idea that grew out of this group to create an entity called Inland Northwest Center for Energy and Decarbonization. And taking an academic license, that works out to be an acronym called INTENT. And that is an entity that will be developed under Urban Nova to execute this initiative. But we didn't want to stop there. There was clearly a lot of momentum around the opportunity to create something. And so there was this topic area 3 on the most recent GRIP funding that came forward. But what was tricky about that, there's a lot of elements that were tricky, but it required 2 states to collaborate. And as a part of this initiative, we got calls from the state of Idaho and the state of Washington to collaborate on funding to be made available to support the deployment or to the execution of this work. And the work is characterized by what you see described here. Utilization of distribution grid, dispatchable loads, distributed generation, and energy storage to manage transmission congestion and limit required upgrades. That's a very aspirational goal with distributed energy resources. But as a part of this process, State of Washington, Department of Commerce, and the State of Idaho Energy and Mining Office came together and worked with us to build a proposal to address this challenge. We submitted a concept paper, and after the concept paper, we were requested to submit a full application, which is due in 5/19/2023, and we have a team currently working on the development of that. The idea that grew out of this talented group, predominantly from Washington State, but AGI and ESIC participation, was could we create, what do we all have in common in regards to these energy districts that are represented in clouds. And that is, they're all electrically connected across our transmission system. And so the question is, could we get these multiple entities to operate their assets in a way, or enable their assets to operate in a way that would provide a certain operational flexibility? So last week or 2 weeks ago, we had a meeting up here at the Morris Center at Avista, and we had representation from every one of these energy districts representing those clouds. And they're all interested in the deployment of this set of energy districts. The state of Washington and the state of Idaho were there, and they are currently creating an idea. This is draft, creating an idea where the Department of Energy, combined with the Washington Department of Commerce and the Idaho Office of Energy and Mineral Resources, would provide funding to intent to provide funding to each of the entities in these energy districts to build infrastructure, not new infrastructure, to augment existing infrastructure or future capital projects in a way that can instrument them and control them in a way that they could be more operationally flexible. And in addition to enabling the facility, it also enables the concept of a lab. This is a common lab shared between all these entities to participate in a variety of research projects, academic projects, or cultural projects for each of those entities. The idea, if the challenge is this, distributed energy resources on the transmission system historically are not material. You can't measure them. So as a part of this, what we're doing is creating a roadmap for how we can deploy these resources where they add value at each scale. So on the left is the scale of resources being deployed. And then on the right is a timeline to do that. And first, it's about essentially creating a framework that those assets don't become stranded at various scales, adhering to various tariff requirements and standards, but initially address a customer platform to address the values of the individual energy districts and the goals that they might have. The second, as they scale more resources, is to be able to contribute on the distribution system to either support voltage or to be able to support peak demand offsets. And then thirdly, to step into the energy imbalance market that the individual energy districts, as they scale up, could be, through our marketing capability at Avista, participate as an energy imbalance market. And the truth of transmission systems is they're not constrained unless a contingency happens. And so as a part of that contingency planning, could they participate at a certain scale in the reserve market, the non-spinning reserve market, as an asset that could be pooled and participate in that? And then finally, as they grow in scale, the aggregation of all these distributed energies resources grow at scale, that they would be able to participate in a bilateral market as well, okay? So that is essentially the roadmap. And you say, well, 18 years, that seems like forever. But how long does it take you to build transmission? 15 plus? So it's not an or, it's an and, this and transmission. But this initiative helps build values as we step forward. So just to finish this, we think of the National Science Foundation, and I'll stop sharing. We think of that National Science Foundation as creating a capability to have market-pulled research to support the development of commercializing products and services that add new businesses in our community that enhance the workforce development, okay? That's the NSF grant. The Regional Energy Platform is in essence a lab. It's the physical infrastructure that a variety of values or experimentation can be done on top of, and provide transparency from the utility perspective, transparency to the stakeholders at the state on the challenges associated with some of these value streams they're looking for. Okay, that's all I have. Okay.
Yeah, thank you for this exciting presentation, John. Any questions for John?
How can we join the efforts that are underway?
Yes. Maybe, John, you should show that diagram where you had the different colors. So the goal or the current plan is the ones who provided the support letters, and those are mostly, we looked at the inland Northwest for the core membership in the program, because that was one requirement from NSF, that we specify the zone where this economic development would be focused in. And the plan is also to grow the zone as the engine gets more mature, and that would include the green colored entities. And so we are envisioning enlarging the center over time. And maybe, John, I should let you answer.
No, Manny, you just did a wonderful job on that. To be successful, you can't, I guess you can try to save the world, but what you want to do is essentially start small and develop a capability and then scale it up as you get momentum and investment into these types of things. And Manny is correct. This is being driven. There's a book titled or authored by two MIT economists on jumpstarting America. And they had this concept of how federal investment can be leveraged in a way to help build industries. And they go through a huge historical chronology of where that has worked. But the challenge today that they see is most of the innovation is occurring along the coastlines. You can think of San Diego, San Jose, Seattle, or Boston, or the Carolinas. The question is, how can we do that in the inner part of our country as well, too? And how can we be very intentional? So our geographical region is this inland Northwest region, which is in essence the Columbia watershed up to the Cascades.
And to answer, I think it was from Anil, wasn't it, the question?
I didn't hear the question.
Yes, Manny.
Who asked the question, please?
Manny, this is Anil. I asked the question.
Anil, oh, okay, yeah, that's what I thought. Anil, we do plan to invite our members to join the initiative as possibly advisors at the beginning, and then as partners as the engine becomes more mature. And so we will be reaching out to all of you. And this is like the first presentation on the initiative. And like John said, this has sort of evolved at an accelerated pace because of the two initiatives that came along, the NSF one first, and then the GRIP initiative, which was announced around Thanksgiving. And so it's happening.
Great initiatives and good timing too.
Yeah, yeah, the timing was just right. We had our brainstorming meeting earlier in 22, and then this happened to come along. And so we were able to jump right in. And John kindly agreed to lead it or to be the cohesive force holding this together. So thank you, John.
Yeah, the only thing that I would mention is, when you get this once of a generation funding, we can either all work individually and try to scrape dollars from it, or we could do something bigger than ourselves. And that is in essence the idea of bringing the whole region into it as a kind of way to differentiate ourselves from all the other types of proposals going out there.
Thank you, John, and we hope we'll be successful in both grants. and we will keep everyone posted.
Thank you.
Next, yeah, that leads right into your presentation, Kevin, to talk about the upcoming GRIP possibilities.
Yes, thank you very much. I've got some talking points from Carl, but John did a really nice job of teeing it up. And I absolutely agree with what you were saying, John. I would make one amendment, is this is our second once-in-a-lifetime opportunity for large funding. the ARA funding being the first one that we thought we'd never see again, and here we are again. But I think your point was well stated, that, and something that we learned from the first time, this is really the opportunity to not try to just scrape a little bit here and there, but let's really take what we've learned over the past decade and figure out how we can leverage this in bigger way, thinking at a larger scale to really have some large impact. And that's really what DOE is hoping will occur from this. When you look at the IIJA and the bill, what they're really looking for ideally is in 10 years, when they look back and say, what did our money buy the country? They want it to look different from ARA. When they look back at the ARA funding, they say, well, we learned a lot. We kind of learned what we shouldn't do here and what did work a little bit here and there. But with this new funding, what they want to do is look back and say, because of these seed investments, these great new things took off, and we have these large persistent capabilities that are not just on the coast, but they hit that middle part of the country as well, and that everyone benefits from. And so I think you really hit that nail on the head there. With that, it's pretty obvious that these resilience grants are going out, GRIP being one of the larger programs for them. As a data point, national labs, what we call federally funded research and development centers, are not able to participate as part of those. Once again, a big part of what the government's trying to do is get something to change on the ground, not just commission studies. With that said, the laboratories are trying to help in that while we can't participate in them through various partnerships, we do try to feed some of the thoughts that are coming from the current research side of the DOE in there to make sure that those grants are building off of the past decade of the research R&D portfolio, giving a little bit of that input. Overall, I would say that some of these have started off a little bit slow in the first year. Probably no surprise for folks that the government trying to go from zero to hundreds of billions of dollars out the door, that was a tough change. And so there was a lot of reorganization with DOE and also within the states. And so just having the human resources of getting the people that you need, both at the federal and state level, I think that's really been a challenge. And so what we've heard from a lot of states is the first year was really a good learning experience, and they're hoping to really be able to capitalize more going forward on this. Especially with, if you look at a lot of these awards, they're expected not just to be a 1 year, we'll send out some money and that's it, but they'll be recurring. Additionally, another data point is that since the labs can't participate in these, oftentimes they will conduct reviews on some of these things. So for instance, P&L is conducting reviews on the cybersecurity plans for a number of the proposals. Since we're not getting money from them, we're good impartial sources of reviewers for those. In addition to the GRIP FOAs, there was the Grid Enhancement Technology, or GETS, that was looking at utility improvement of clean energy capacity and technologies. We've heard that DOE received a number of those, mostly from large utilities. P&L was supporting one smaller one, but that was another one of these projects that was going out. Another big area that I'll say a little bit about was the technical assistance resources for utilities and communities. DOE has talked a lot about technical assistance, and I think when this first came out, there wasn't really a clear understanding of what is and what isn't technical assistance. It's kind of viewed in a number of different areas now, and some of that is kind of starting to shake out. But really, part of the goal there is to get technical assistance in various forms to states and different stakeholders, such as historically underserved communities, tribal communities, rural communities. Because as was mentioned before, a lot of these emerging technologies and newer concepts, they're not very accessible to remote areas that don't have a strong research and development background like the Pacific Northwest does, as John mentioned. Because of the history of the hydro and everything else up here, we're very fortunate. Even with that, as you saw from John's presentation, there are still communities that really aren't as able to access these. And so in other parts of the country, you start to move inland, I can only imagine there's a number of folks in North Dakota that just aren't really well suited as, say, an Avista to go after these. So there's a lot of activities looking at how do we, I don't want to say level the playing field, but make these resources and capabilities accessible. And they're still trying to figure out exactly what will be all the forms those will look at. So we are seeing some that will directly target historically underserved communities. But then there's also programs that are looking at how to support the PUCs as a whole. Once again, I don't believe anyone has a one-size-fits-all solution to this. They're trying a bunch of different things, because when you say something like diversity or inclusion, it means a lot of things to a lot of different people. The one comment that I will say, with no inside knowledge to be clear, that I believe that they're going to be receiving DOE will be receiving a lot of proposals. And if you see proposals like the one that John was presenting, where it really says, here's what we mean by including different segments of our community, here's what it means for these community members, that's the type of thing that DOE is really going to be hungry for in these proposals, because they don't have all the answers. So that if they see teams coming together with a mixed portfolio of stakeholders and they're all agreeing, with all our different sets of interests, here's what we're looking for, those are things that are going to resonate very well with DOE. They're not just going to be looking for the best technical solution. We've tried that before, it doesn't always work. And so they're going to be giving weighting to some of those non-technical factors. Now, obviously, it still has to be technically sound. That's a given. But the folks that bring that broader stakeholder set in will really be in a good position. I think that's probably where I'll leave it at, is just saying that DOE is hungry for these ideas and this engagement of what does it mean to really bring everyone to the table? And more importantly, or I should say equally, what's going to give us persistent long-term impact, so that when at 10 years down the road, they can look back and say, because DOE invested X dollars, we now have programs and capabilities that span this region, this set of stakeholders, and they can really claim that there was a benefit to it. And really, from a taxpayer perspective, what we're really saying is we want to see a good return on investment in these. They want to say that, yes, once in a lifetime investment, it costs a phenomenal amount of money, but because of that, we have even greater returns. And so I think I'll leave it there unless there's any specific comments or questions.
Well, Kevin, thank you for that. The only comment I'll make is that Avista's never really had a good idea. It's only gotten good ideas from the national labs and universities.
Well, I appreciate that, John, but I've sat in on some of the meetings where you guys have gone through with some of that, and I've been absolutely impressed by how much work you guys have done compared to some of the others.
Only through our partnership with you guys. That's the only way it's worked that way.
And I saw on the chat, thank you, Noel. I am wearing my WSU hoodie because I showed up to a meeting without wearing one. And then she told me a gift card was in the mail, and don't make that mistake again. So go Cougs.
Thank you, Kevin. Much appreciated. And I like what you said, that even though this was, it seemed like a lot of work and a lot of money. The reality is, like you said, the GRIP funding is just what we went through was just the first round of proposals. And there is going to be an annual opportunity.
One other thing I would add to that is, even though it is a phenomenal amount of money, it's nowhere near what's necessary to get the job done. And that goes back to John's comment of, this is the public-private partnership. This is the seed money that shows this can be done, and it should keep going, and there is benefit.
Yeah, and you are absolutely right, Kevin, because when we talk to our partners in Europe and the kind of resources that they have for developing technology for field demonstrations, I think on the US side, we are just getting started. And it is absolutely the right time that the government has taken this position to provide the funding for these exciting opportunities. Yeah, thank you very much.
I would make the comment that 10 years ago is always the right time for this type of investment, but here we are today. Looking forward.
Yeah. Thank you. On that note, I know we haven't had much time for comments and participation from our board members. So please feel free to join the conversation. Maybe you can talk about your plans and how you had coordinated for the GRIP initiatives or other infrastructure funding related initiatives. I know, Jay, you were leading a team for the GRIP program, or at least that's what I heard. I don't know the details. I don't know if you are willing to share anything.
I guess I could talk a little bit. Yes, I was graciously asked to take on developing plans and projects under the IIJ funding by our good friend Larry Beckadall. So something you can't say no to. It's been really rewarding so far, but we are working just like everybody else. We're working, with different partners, and we're putting in applications across many different areas under the IIJA, from research type grants, looking at inverter-based resources and grid services. We're partnering with PNNL and others on that one to use our Wheat Ridge facility, which is first in the nation type of a renewable energy generation center with battery, solar, and wind. We've got other, I've got, as you many of you know, there's a deadline for topic area 1 is next Thursday, so we're quickly going towards that one. We have an interesting project we put together for topic 2, what we call the smart grid grants. Using the power of NVIDIA GPU processors at the edge of the grid to do analysis and analytics and look at a lot of the issues that some of your researchers were talking about, and how do we control these resources and utilize them to our best ability. And also, we're involved in topic 3 also, very large partnership and transmission infrastructure type of project. So we're going after that. But yeah, multiple areas. All told, I think the projects total almost $1 billion under the that we're going after. So about $500 million worth of grant funding. Don't think we're not going to get everything we asked for. Like I said, there's just more need than there is dollars to go around. But we hope we're successful on some of them.
Yeah, awesome. Thank you for the update, Jay, and let's hope all of us get all the funding so that we will stay busy. It seems like you will be, or you are already very busy putting together these multiple initiatives. So I know that's a lot of work.
Yeah, it is, and I'm like the sole proprietor of this organization. So,
so I would just mention that on any topic, if any of us can help from WSU, you please let us know. And also, if there are some topics that we should be looking at in terms of research that would fit the needs of the industry, please feel free to let us know at any time.
Absolutely. Thanks a lot.
And anyone else on the plans and activities that we should be looking at? Let me see.
Yeah, this is Chuck at.
Chuck, please go ahead. Yeah.
Yeah, this is Chuck at Vice. It's very clear to me because we also, plan to bid on 3 of the GRIP projects. Unfortunately, 2 of them, didn't pan out. But the basic concept is collections of microgrids and using the microgrids as control actuators of the grid. And this is something that I think is a good approach to build microgrids that are very fast and that are able to respond to external commands at 200 milliseconds or faster. This is required by the ERCOT fast frequency regulation market, for example. So it appears to us that having lots of microgrids that can work together and that can participate in energy markets, multiple markets at one time, makes a lot of sense. And I think that what John said makes sense about having the microgrids do two functions. It can dramatically improve the resilience of the grid. In fact, the seminar yesterday by the professor from Massachusetts, it really struck a point with me when he showed the resiliency curve. And Manny, you specifically asked a question that really also was intriguing about if you follow this resiliency curve, then you should be able to learn from the event, and you should wind up at a higher level than you started with, which I think is exactly what we view as an approach of having these collections of microgrids operating together, to control the grid from the bottom up. So we're hoping that this approach will take off, and we do know that if people really think about the microgrid as a valve, that can be operated very fast.
Yeah,
So
thank you. Yeah, thank you for the feedback. And in fact, we hope PICE will join ESIC and that we will be able to collaborate as a team with all our partners. So that's something that we look forward to. And it's maybe we can chat offline on the other initiatives. And Anil, do you have a comment? Please go ahead.
Mani, this is about the practicum schedule.
Practicum.
This year,
okay, yeah.
Yeah. This year we got lugged out, and I spoke to Daniel Christian at University of Washington. Even though it was the finals week, he found 3 students that were interested in power industry to join the practicum, along with 2 students from WSU. There was no fight between the Cougars and the Huskies. But it went very well, and the way they were able to collaborate and work together, I think it worked out well. What I'm getting at is, in the future, if there's more collaboration between universities within the state or even Idaho and other places, that would be beneficial for the Northwest region.
Yeah, that's a nice thought, Anil. We can think about, we are discussing how to scale and grow the practicum program. For instance, we are going to be inviting students from our Vancouver campus and also our Tri-Cities campus to join the program. And one of the key features of the program is the program should not cost any dollars to the host companies, in that we provide the resources for the travel support for the students from the membership funds. And so it'll be interesting to see how we can scale it up and also keep the resources that we provide to the students. And so we would be very happy to discuss with you, and maybe this should be on the agenda for the PEP meeting, Linda, on how we maybe include participation from a broader set of universities. Even what you are suggesting is to go beyond even WSU, and to maybe we can do that in stages, like what John talked about in terms of scaling the initiative that he proposed. So here again, practicum, we can come up with a 5-year plan and a 10-year plan, what this program should look like in the future. And then we can gather the resources. We can pull together the support that is needed to really grow the program, because I agree with you, it's clearly very successful. This year, like I said, we got some students from computer science and computer engineering. We were really surprised, because in the ad, we said it is restricted to EEs. But then the students, out of their own interest, they volunteered or they applied for the program, and we included them because the partners were willing to host them. So I think we have a real growth potential for the program, and we will really look forward to continuing this conversation in our April meeting.
And I was also encouraging them to submit posters for the IEEE general meeting.
Yes, yeah, we do that here
Yeah,
too.
they really took on that idea and then they were actually collaborating among themselves.
Yeah, and we sent them to the NAPS meeting as well, which is the other
Nice.
student-focused conference. And so,
Mhm.
yeah, I think we can chat during the PIP meeting, and maybe we can even
Wonderful.
have a conversation ahead of it, and then put this on the agenda for the PIP meeting. And we appreciate
Wonderful.
all your support, Anil, and everyone
It's our
who
pleasure. Yeah.
contributed to the
Thanks.
practicum program. Yeah, this year we had the largest. I was really happy to see, and I should thank Linda for all her work in coordinating, and also Javier, who put together the events with the companies. Maybe on that note, I know we are running out of time and it is end of day. So if there are any action items that you would like to propose to us, how we can better serve you, please send a note to me or Linda, and we would like to follow up on that. And one of them will be this practicum, Adil. So if there are other action items, please, we have maybe a minute. So any last thoughts or suggestions for ESIC? I see something in the chat and okay. Yeah. Thank you very much. I think this is maybe all we have for today. And really, like Kevin and John said, it is an exciting time, once in a lifetime, or maybe the second opportunity in the lifetime. And so we are all looking forward to working with you. Thank you so much. Have a good evening.
Thanks.
Bye.
Yeah.
Thank you. Bye-bye.
Bye-bye.
Thank you.
Thanks.